Hello, ladies and gentlemen. We're going to hit 2, 3, 2, 4, 2, 5 here, go through all the polynomials that we've been working with. First thing we're going to do is start off with some of the graphing. This was what we hit pretty heavily on the first quiz. So if it's already in factored form, the first thing you want to figure out is what is the degree of the polynomial. And you got to remember that you're going to, if you're in factored form, you got to add up the degree of each factor. So you have 1, 2, 3, 4. So this thing is degree 4. That's where we got to start. You also need to know, is it going to, if it's degree 4, does it open up or down? Since it's a negative leading coefficient, it's going to open down. So I know it's going to look something like an M. What I have to do is also figure out where the zeros are. So if negative x is a 0, then 0, or is a factor, then 0 is a 0. If I plug in 0 here, this whole thing goes to 0. Also is true at positive 2, because 2 would be a 0, and negative 1. So my three zeros are at negative 1, 0, and positive 2. Now I'm going to start to draw it, and I have to kind of have a game plan here. This is an odd multiplicity, and this is an odd multiplicity. So if these are both, I'm looking at the degrees here. That means they're going to pass through 0, and they're going to pass through negative 1, but this is an even multiplicity, which means it's going to bounce off a 2. It's going to bounce off a 2. So if I try and build this thing now, it's got to pass through, and then it's going to bounce off. So it goes up, passes through, turns around, passes through, and then when it comes up this time, it's going to bounce off. And I know it bounces off because this is an even multiplicity. It's degree 2. So pass through, bounce, and that's your polynomial. I'll come back to the end behavior. This next one is not in factored form, which means the first thing you're going to need to do is factor it. And I'm going to see if I can first just factor out a negative because this bothers me. So negative, and now I have 2x cubed plus 4x squared minus 8x minus 16. Now I'm going to try and factor this. To factor that, let's see, does grouping work? I think it does. I'll do 2x squared as my GCF, and I have x plus 2. And then over here I have minus 8, x plus 2. I still have a minus sign out front. So this is negative 2x squared minus 8 and x plus 2. So my GCF, I probably should have factored out more. Let me keep working on this. I didn't realize they were all even. See how these are both even? I should have factored out 2. So I'll factor out a 2 now. Negative 2, x squared minus 4, x plus 2. Wait a minute, that's still factorable. So this is x plus 2, x minus 2, and then I have another x plus 2 with the negative 2 out front. And now what you have to realize is you have 2 of those x plus 2's, so that's negative 2, x plus 2 squared, which is now going to make this a multiplicity. That's going to definitely affect what happens on the x-axis. So now when I start to draw it, I need my zeros at negative 2 and positive 2, negative 2 and positive 2. And this is degree 1, 2, 3, so it's odd. It is negative, so it's going to look something like that. And I know it's going to bounce off of negative 2 because this is an even multiplicity. So it comes down here, bounces off, then it turns around, and it's able to pass through like that. Now let's talk about the end behavior. To describe these end behaviors, you need to use limit notation. Limit notation has to look exactly like this. You cannot in any way change this. We're going to say the limit of the function p of x as x approaches infinity, which means as you go to the right, what does the function do? It goes down, so it goes to negative infinity. The limit of p of x as x goes to negative infinity, so as it goes to the left, it also, y is going down, so it is also negative infinity. Over here, the limit is the function p of x again? Yeah, p of x. The limit of p of x as x approaches infinity. As you go to the right, y goes down, so that is negative infinity. And then the last one, the limit of p of x as x goes to negative infinity. As you go to the left, x goes to negative infinity to the left, y goes up, so we say it goes to positive infinity. It must look exactly like that. That's your limit notation. So we factored, we graphed, we got x-axis behavior, we got limit behavior. What else do we need to do? Polynomial long division. Okay, so for long division, the big thing is when you see these sorts of problems, my biggest suggestion is regardless of what kind of division, you want placeholder zeros. If you don't put placeholder zeros, this can become really tricky and obnoxious. So what I'm going to do is for my my divisor, x squared plus 0x plus 3, I'm going to put a 0x in the middle. Now, I'm trying to figure out what I got to multiply x squared by to cancel out x to the fourth. That would be x squared. Now, I need to distribute x squared into this. So x to the fourth plus 0x cubed plus 3x squared. When you distribute the x squared, you get that. And then you got to remember, all these signs have to flip. Negative, negative, negative. So that cancels out. This doesn't matter. You still end up with 4x cubed. And 4 minus 3 is plus 1x squared. And I'll bring down the 12x, and then we just do it again. So to do it again, I got to figure out what I got to multiply x squared by to get 4x cubed. That would be 4x. Now I will distribute a 4x. 4x cubed plus 0x squared plus 12x. And now I subtract. Minus, minus, minus. Those go away. 1 minus 0 is still 1x squared, and those go away, so plus 0. I'm going to put 0x again just because I think the placeholder makes it a lot easier. One more time. X squared times what is x squared? 1. And now I go ahead and distribute a 1, which is x squared plus 0x plus 3. Wait a minute. So when these all cancel out, minus, 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 cancel, 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 you get 0. So the remainder is 0. Now the question is x squared plus 3 a factor? And the answer is yes, because when we divided, there was no remainder. If there's no remainder, that means you're talking about a factor. So x squared plus 3 is a factor of this. And in fact, I could then take this, and if I wrote my answer as quotient times divisor, let me go ahead and do that. Quotient is x squared plus 4x plus 1 times my divisor, x squared plus 3. Not only is it factorable, I factored it. So we're good. If I wanted to find zeros, I would do quadratic formula, but I don't care to do that right now. It is a factor because the remainder is 0. Use any method to determine if -1 is a 0. Well, let's see. We could do it synthetically, where we plug in -1. But the trick to this is you got to remember that you can't have any missing zeros. You'd have a 3, and then you have so that's degree 8, degree 7, degree 6, degree 5, degree 4, degree 3, degree 1, or no, 2, degree 1. So you got all these zeros, which is weird. And you're like, okay, what happens here? -1, and then it's going to be -1, and then it's going to be 1, 1, -1, -1, 1, 1, -1, -3. What's going on here? This is just going to take a while. I feel like I did something wrong anyway. So let's not think about it that way. You can do long division. Again, that's a long way to do this problem. If it is a 0, what does that mean? It means when you plug it in, you get 0. Does this equal 0? You don't need a calculator for this. -1 to the 8th is 1, so that's 3. -1 to the 3rd is -1, so that's plus 2, plus 1. No, this is not a 0, because when you plug in -1, you get 5. If I plug in -1 and I get 0, then I know it's a 0. So you just got to be aware that there's multiple ways to approach these problems, and the synthetic division isn't always the best. Just plug it in the old-fashioned way. List all potential zeros. So this is called the rational zero theorem. What we're going to do is list factors of the leading coefficient and factors of the constant term. And then we're going to always take 1 divided by this. So since it's just a 1, it's plus or minus 1, plus or minus 2, plus or minus 3, and plus or minus 6. Now what I need to do is find a 0. So I got to figure out basically where I'm going to start. Now, there are, 8 different options here that I could work with. So this might take a little bit. So I'm going to start with, let's see, what do I want to start with? Let me see. I'm going to kind of speed this along a little bit. X squared minus 4x. Okay. X cubed plus x squared. I'm going to game it a little bit just for the sake of this going quicker. Let's start with, I don't know, we'll try positive 3 and see if that works. So if I do positive 3, I'm going to do synthetic division. 1, 1, -4, 6. 3, add 4. 3 times 4 is 12. add 8. 3 times 24, it ain't 0, it doesn't matter. Okay, so 3 doesn't work. What if we try negative 3? And sometimes you might have to try a bunch of different things. But let's see. Negative 3, 1, 1, negative 4, 6. So bring down the 1, negative 3, negative 2, 6, 2, negative, hey, we got 1. So since negative 3 worked, that is one of my factors. So what I'm going to do is I'm going to write now my quotient, which is x squared minus 2x plus 2, because you drop it degree. It was a cube, now it's a squared. And my factor that I just factored out was x plus 3. Since negative 3 is a 0, x plus 3 is a factor. Now I need to decide if this is factorable, and I don't think it is, which means I have to do the quadratic formula, negative b plus or minus b squared minus 4ac all over 2a. So in this problem, b is 2, that would be 2 plus or minus b squared, negative 2 squared minus 4ac over 2a. 2 times 1 is 2. So that's 2 plus or minus 4 minus 8 is negative 4. Okay, which is nice. When you see this is called the discriminant is negative, I'm going to have two complex zeros. So the square root of negative 4 is 2i. And then to write it in standard form of a complex number, you got to distribute that 1/2, so 1 plus or minus I. So 1 plus or minus I are two of my zeros. I'm going to say x equals 1 plus or minus I, that's two of them, and the third one is negative 3, and that is all my zeros. And the fundamental theorem of algebra says if it is a cubic, you should have 1, 2, 3 zeros. So we do. We got them all. Write a polynomial in standard form with plus and minus 3i. So this is kind of, I don't really need to tell you that one, because if x minus 3i is a factor, then x plus 3i has to be a factor. It's called the complex conjugate theorem. So I could just say there's one of them and it's a cubic. They always come in pairs. But here I gave you all three. And then x minus 2 if that's a 0. So the trick to this is you want to expand this first with the complex numbers. And you might be able to do it in your head. I can do it. It's going to be x squared plus 9. But let me show you why. X squared plus 3xi minus 3xi minus 9i squared. So those cancel out, and then you have x squared minus 9i squared. That's negative 1. Negative 9 times negative 1 is positive 9. There you go. Now we just need to go one more step. So we're going to expand this guy out. X cubed minus 2x squared plus 9x minus 18. Hey, we're done. We did it. Okay, standard form. Just expand it all out. And that's pretty much it for the test. If you can hit all those things, there might just be a couple other extra types of problems, but they're all going to use these concepts. If you can do this, you're good to go. So go ahead and hit that like button.